examples for the friction lesson. So hopefully it went okay with the homework from last week and you're ready to start going again. At this point, my assumption is that you've read through the lesson, you watched the videos, and you're ready to do these examples with me. Okay, so we've got, you've been home and you're bored and you're reorganizing your room and you want to move your bed to a new location. You try to apply a force of 127 newtons, but it's not big enough. We need to figure out what the static friction force is in this case. So we're going to draw an interaction diagram. Your system here is the bed, of course. So our system experiences a normal force and friction force from the floor, your applied force, and of course gravity. From this, we can draw a force diagram. It's not accelerating in the y direction, so we have a balanced forces. And as you know, your, which way are we going here? Let's just say that your applied force is to the left, and your static friction force is to the right. We also know that this thing hasn't moved, so those two forces, they're different size than Fn and Fg, so they get 2 ticks, but they're also balanced. Okay? So our net force in the x direction is equal to Fa, well, let's say that this way is positive. Okay? Fa take away Fs, and that's equal to 0. So Fa equals Fs, and Fs equals, our applied force was 127 newtons. Okay, so that's Newton's first law. It's asked us to find the F net y equation as well. So that's normal. Fn minus Fg, that's also equal to 0, so Fn is equal to Fg. Okay. Which, you know, may or may not be useful in terms of the question that you're doing, but that actually is quite useful when you are doing problems and you don't know what Fn is. If you were to continue on and you knew the mass of the object, you could just go m times g and then figure out a value for your normal force. In example 2, we get more information, we get more muscles, and we push the bed with a new force of 247 newtons. It starts moving. Kinetic friction coefficient is 0.53, and our bed has a mass of 41 kilograms. Let's draw our new force diagram here. Okay, so we're still pushing it to the left. But now our applied force is bigger than our friction force, and in this case our friction force is kinetic friction because we're moving. Our normal force and our gravitational force are still balanced, and we're accelerating to the left. We'll say that left and up are positive. Okay? Determine the acceleration of the bed. Okay, oh, so sorry. How is it different from the one example? 1, we know that now our net force in the x direction is not equal to 0, right? Because we have unbalanced forces. Find the acceleration of the bed. So we're going to use the forces in the direction that the object is accelerating. That's the x direction. Fa take away Fk equals ma. Newton's second law, okay, rearranging for acceleration. We go Fa take away Fk over mass. We know Fa, we know mass, but we don't know Fk. We know the equation for Fk is mu k Fn, okay, but we don't know Fn. So we're going to use our F net y equation to solve for Fn. So Fn is equal to Fg, which is equal to mass times gravity. So we can plug that straight into there, which can go straight into there actually. So I'm going to go FA, take away mu K mg, right? Because normal force is equal to the weight in this case, not always, over the mass. Now these masses do not cancel out because I do not have a mass in this part of the equation. Don't cancel it out. So my acceleration is going to be 247 minus 0.53. I'm totally going to run out of space. Divided by, and we get 0.83 meters per second squared to the left. Okay. All right, so a couple of things to remember. Write out your F-net equation in the direction that it's accelerating. Plug in your force of friction equation. You're going to have to find your normal force using the F-net Y equation, and then plug in all your values as according to what has been given. Okay, so you're going to try a little bit of this with your homework and then check your answers. Thanks.